Alright, welcome to the next video in 7. I think this is the beginning of video 7. Alright, compounds containing polyatomic ions. Table 2 on the next page lists some common polyatomic ions. Let's look at let's look at the next page for that table. Alright, some polyatomic ions, NH4, dimercury, check them out. These are also on the slideshow I've made available to you for practice. You need to memorize all of these ions and their formulas and their charges. Most are negatively charged, and most are oxyanions. Polyatomic ions that contain oxygen. Oh yeah, that sounds like a great quiz question. Some elements can combine with oxygen to form more than one type of oxyanion. For example, nitrogen can form NO3- or NO2-. The name given a compound containing such an oxyanion depends on the number of oxygen atoms in the oxyanion. The name of the ion with the greater number of oxygen atoms ends in -ate. The name of the ion with the smaller number of oxygen ends in -ite. So for example, we have nitrite and nitrate. Sometimes an element can form more than two types of oxyanions. In this case, an anion has one fewer oxygen than the ite anion. Next page, which is 226. And is given the prefix hypo. An anion that has one more oxygen atom than the ate anion is given the prefix per. The nomenclature is illustrated by the four oxyanions formed by chlorine: hypochlorite, chlorite, chlorate, and perchlorate. So basically, chlorate is 8 is the reference. It has 3, ite has 2, hypochlorite has 1 oxygen, and perchlorate has 4. Know 'em all. I want you to know these as well. Quiz. Compounds containing polyatomic ions are named in the same manner as binary ionic compounds. The name of the cation is given first, followed by the name of the anion. For example, the two compounds formed with silver by the nitrate and nitrite ions are named silver nitrate and silver nitrite, respectively. When multiples of polyatomic ions are present in a compound, the formula for the polyatomic ion is enclosed in parentheses, as shown on page 220 for aluminum sulfate, right there. The formula indicates that an aluminum sulfate formula unit has 2 aluminum cations and 3 sulfate anions. Check that out. All right, please go to page 227. Take out the paper on which you're doing your sample problems, because we've got another sample problem to do. Do it along with me. If you're choosing not to do it, you're choosing basically to not get all the points for your notes and not know what you're doing on the quiz. So basically it says write the formula for tin 4 sulfate. All right, well that's something we can do in our sleep, right? I hope so. It's basically the exact same thing that we've been doing all along. All right. Tin 4 sulfate. It says first, write the symbols for the ions side by side. Start with the cation. Okay, so this is problem number C. Start with the cation. It is, right, SN4 plus and SO4 2-. All right. What's the next step? You got it. Crossing over. So go ahead and cross over. So we have 2 and 4. We're going to use parentheses to show that we're using a polyatomic anion. All right, what's the next step? Well, make sure that the charges balance. We can do that. So 2 times 4 plus is 8 plus. 4 times 2 minus is 8 minus equals 0. Okay. So what is our whole number ratio? It is 2 to 4. Is this the smallest whole number ratio we can come up with? Probably not. What is the largest common factor? Largest common factor, 1 times 2. I think that's all we got. But with 4, we've got a couple. We've got 1 times 4, we've got 2 times 2 equals 4. The largest common factor I'm going to circle in blue looks like 2, the largest common factor. So if we divide this by 2, we're going to get the whole number ratio of 1 to 2. Mr. Worley, I could have done that in my mind. I can see that 2 to 4 is the same as 1 to 2. Yes, sometimes you might need to do the math, and that's why I did it here for you. So go ahead and write the formula. It is SN1, so no subscript, parentheses, SO4, parentheses closed, 2. Is that what the book said? Yes, right there. Good job. All right, so basically it's the same exact thing, just this time with polyatomic ions. You need to know how to do these kind of questions. They should be on the quiz. You can do it. All right, let's continue moving on. I'd like you to please focus your attention after finishing up that practice problem on naming binary molecular compounds, and please go to the next video.